Building Material Testing Laboratory. Today in Building Material Testing Laboratory we are going to find grain size distribution of a fine aggregates. In this test we are going to refer various IS code like IS 2386 Part 1 1963, IS 383 1970, IS 460 1962. Now, according to IS 460-1962, we have used various sieves like sieve of size 10 mm, 4.75 mm, 2.36 mm, 1.18 mm, 600 micron, 300 micron, 150 micron and bend. We are going to use weighing balance, gauzing trowel, stopwatch and shear shaker. Now the material used is a sample of fine aggregates. The sieve analysis is conducted to determine the particle size distribution in a sample of aggregate, which we call gradation. Many a time fine aggregate are designed as a coarse sand, medium sand and fine sand. Finest modulus is used to classify the fine aggregates. Finest modulus for a given aggregate is obtained by sieving known weight of it in a set of standard sieves and by adding the percentage weight of material retained on all the sieves and dividing the total percentage by 100. It serves the purpose of comparing one aggregate with another in respect of fineness and coarseness. For classification of fine aggregate, limit of finest modulus are fine sand 2.2 to 2.6, medium sand 2.6 to 2.9, coarse sand 2.9 to 3.2. After conducting the test, the observation table is compared with the table number 9 of IS 383-216 for classification of fine aggregate according to different grading zones. kg of a fine aggregate sample, we place this sample at the top of the sieve arrangement. We allow sieving of the sieves for 10 minutes either manually or through the sieve shaker. On completion of sieving, the material retained on each sieve shall be weighted using weighing machine separately for each sieve. Now after taking all reading, observation table is filled as. In this there is a different columns. Column 1 is of serial number, second is of IS sieve, third is weight retained on sieve in grams, fourth percentage of weight retained, then cumulative percentage retained, then last is percentage passed. In sieve, IS sieve 10 mm, weight retained is 0 grams, so the percentage of weight retained is 0, cumulative percentage retained is again 0 and percentage passed is 100%. In IS 4.75 mm sieve, weight retained in gram is 100 gram, so the percentage of weight retained is 5, cumulative percentage retained is 5, so the percentage passed is 95%. Similarly, we complete the table for different sieves. After it all calculation is done, after this we have to go for calculation of finest modulus. Finest modulus is an empirical factor obtained by adding the cumulative percentage of aggregate retained on each sieve, dividing this sum by arbitrary number 100. So in this test we achieve the value of finest modulus is 3.1. So from result obtained we can see the type is coarse sand whose value of finest modulus lies from 2.9 to 3.2, as we have attained the result is 3.1, that lies between 2.9 to 3.2. So according to IS 383-2016, as we have achieved the results, the grading zone we achieved is of zone 4. Precautions should be taken during this test. The sieve should be cleaned before using. The weighing should be done accurately. Shaking of sieves must be done properly. Thank you.